Hi everyone, and welcome to your first off-campus lesson. Today's lesson is on Chapter 2, Matter, Change, and Energy. We're going to focus on properties of matter. You should have your note set with you and the assignment to follow along after. Both of these can be found in Google Classroom if you don't have either one. The goals of this section are for you to be able to identify properties of matter as extensive or intensive, define physical properties and list several common examples, and also do this with chemical properties. You should also be able to differentiate among the three states of matter and describe a physical change. So let's get started. What is matter? Matter is anything that has mass and takes up space. That means that it has to also have volume. So what are we talking about? The simplest forms of matter are the smallest particles we can find, which we refer to as atoms and molecules. Atoms make up elements. And molecules make up compounds. So we can say it either way. The simplest forms of matter are either atoms and molecules or elements and compounds. So that pretty much means everything that we can think of on Earth. So let's list some examples of things that are not matter. Things that are not matter are usually different forms of energy. So for example, heat is not matter. Electricity is not matter. Light is not matter. Sound is not matter. Again, these are all forms of energy. These can be given off or absorbed by matter, but they are not matter themselves. Question always comes up about air. Is air matter? To answer that question, I need you to think about whether or not air has mass and takes up space. I'm going to ask you to explain this to me in the question in the Google Classroom. I want you to explain whether or not you think air is matter. And I need you to give me an explanation of why. So that's your Google Classroom question for the day. So after thinking about what it means to be matter, I want you to explain whether or not air is matter and also maybe how you could prove it. All right, so I'm going to ask you in class what you guys came up with to that, but post your answers in the Google Classroom question area. So when we describe matter, we usually focus on our observations. We look at properties used to describe matter and classify them as extensive or intensive. Extensive properties depend on the amount of matter you have, while intensive properties depend on the type of matter you have. So I will have an example of this in class for you with sugar. If I had a cup of sugar versus a bag of sugar, what about that would change? So think of these two things. I have a cup of sugar and I have a bag of sugar. They're both sugar, so I want to know what is going to change and what's going to stay the same about them. Both of them are the color white. Did it matter how much I had, or did it matter what I had? Since it mattered what I had, color is an intensive property. It's internal to that object, that compound. What about taste? Would a cup of sugar taste different than a bag of sugar? No. So it wouldn't matter how much you have, it would matter what you have. So taste is an intensive property. So what would change about those two things? There are only two things we usually discuss as extensive properties. Those are mass and volume. Everything else that we can think of is probably an intensive property. Color, taste, texture. All of these things would be considered intensive. In addition to extensive and intensive, we also refer to properties as physical and chemical. All right? Physical properties are properties you can observe with your senses. You do not need to make any changes to the matter to observe it. While chemical properties are properties that can only be observed by testing the matter to see if it changes. So a physical property, this sheet of paper is pink. Do I need to change it to tell me that it's pink? No. So color is a physical property. Is this paper flammable? You would have no way of knowing unless you actually tried to light it on fire. So chemical property would be considered flammability, because they would actually have to do that thing to prove whether or not it is flammable. Taste is physical. I don't have to change it into something new to tell you what it tastes like. Texture is a physical property. Whether or not something will rust if left out in the rain, I might actually have to leave that out in the rain to see whether or not that happens. So rusting would be considered a chemical property. Color, taste, texture, boiling point, melting point, all of these things can be done without actually changing the matter into something new. I can figure out what the boiling point or melting point is of water without changing it into something new. So this then also leads us into physical and chemical changes, which are kind of similar. Sometimes we can change something and we can undo it. Or we change it and it doesn't change it into a new substance. Those are physical changes. For example, if I freeze water, I can reverse that by melting it. And I didn't really change it from being water, so that's a physical change. If I fold paper, I didn't change the paper into something new. Or even if I cut paper, I didn't change it into something new. If I boil water, I'm not really changing it into something new. So those are all physical changes. If I break glass, I didn't change it into a new substance, but I can't really reverse that on my own. It's still physical though. Usually both of these things are true, but as long as one of them is true, we can say that it's probably a physical change. Chemical changes, we can't usually reverse them, and it does change it into something new. I'm going to do an example of a chemical change for you in class for you to see, and you'll see that we can't reverse it, and we did get something new out of it. So usually when I burn something, I can't undo that. If something rusts, can't undo that. Other words to look for would be corroding, is something that we can't undo. Tarnishing, fermenting, cooking. All of these things are things we can't undo, and they changed them into something new, so those would be considered chemical changes. We often discuss states of matter here in the beginning too. I want to make sure that we are clear. Water has some special names depending on what state of matter it's in. So for example, sometimes we just refer to water like in the water state. That's not really a state. Usually when we're referring to water, it's at room temperature, and that's the liquid state. Ice is what we get when it's a solid, and steam is what we get when it's in the gaseous state or a vapor. Again, not a big deal. These are just three terms that are often used for water and nothing else. All right. States of matter is something that I believe you guys are all familiar with, so this is review, and there's not much to write down on here except just make sure that we're aware of it. We usually describe a solid as having a definite shape and definite volume. That means it doesn't change. The shape of a solid does not depend on its container. If I poured rocks from one container to another, the rocks are not going to change their shape. We say that the particles are tightly packed and in an orderly arrangement. This means that they're incompressible. Incompressible means you can't reduce their space. Another word for space is volume. Again, think of particles in a solid as closely packed together, vibrating but not moving their positions at all. Moving on to liquids. Liquids are in close contact with one another, but the arrangement is not orderly. The particles are free to flow, and we describe them as having an indefinite shape, meaning they can take the shape of a different container, but a fixed volume. That means I'm not changing the volume if I pour from a small glass to a big glass, but I am changing the shape. So the word fixed means not changing. The word indefinite means it can change. And liquids are incompressible but do expand slightly when heated. That's why warm water will float on the top of cool water because it's not as dense. Right? And again, remember that we describe liquids as free-flowing and not as orderly. Gases do take the shape of their container, like a balloon, or your lungs, or a tire. They do expand to fill any volume. If I opened up a bottle of perfume from one end of the room, those particles would expand and, drift out of there as they evaporated to fill up the entire room. Particles are farthest apart, and because there's spaces between them, it allows for easy compressibility. Two terms that are often used interchangeably, which is okay, but they mean different things. Gas and vapor are not the same thing. Okay? Gas is a state of matter and it's used to describe matter at room temperature. But a vapor, which, yes, is something changing into a gas, a vapor is not a state of matter. It's not something at room temperature. A vapor is a liquid forced into the gaseous state. By adding heat. So these are two different things. A vapor didn't really want to be in the gaseous state in the first place. And a gas is naturally in a gaseous state at room temperature. All right, and so then some changes in matter that we should be aware of are these over here. Some of these you've heard of. I want to describe how you work heat into that as well. So if I took a vapor and changed it into a liquid, that means I'm cooling it down. So in order to get a vapor into a liquid, you have to remove heat, which we're going to say minus H. That is called condensation. A liquid to a vapor is the opposite. That's like boiling something. You have to add heat to do that. That is called evaporation. A solid to a liquid, adding heat. That is called melting. And you are familiar with that one. A liquid to a solid, we would have to remove heat. I know that that is called freezing when we're dealing with water, but we're going to refer to that as solidification because it doesn't always have to be cold. When you use the word freezing, it implies that it has to be cold. Sometimes you can get a solid that turns right into a vapor. Dry ice is an example of this. In order to get that to happen, you have to add heat, and that is called sublimation. So pretty much you're skipping the liquid state altogether, and that solid is going right into a gas. The opposite of that is when a vapor turns right into a solid. You would have to supercool that, so you'd have to remove a lot of heat, and that is called deposition. And that is pretty much it for our notes. That was quick and painless. Just a few slides here to get you started. So your assignment now is to go back into Google Classroom and answer the question that I have there about whether or not errors matter and explain how you would prove it. And then your assignment is to complete the worksheet that I gave you that goes along with it on matter, change, and energy. You're going to answer some questions basically from the notes. If you have any questions, you can email me in Google Classroom. I'm always there to help. Have a great night. Enjoy your day off.